Graphs of composite trig functions. The graphs of sine, cosine, tangent, cotangent, secant, and cosecant can be transformed by either shifting, stretching, shrinking, or reflection. Examples of the elementary transformations are captured in notation as follows, with 6 trigonometric functions. Translation: shifting up or down. Sine x plus k, cosine x plus k. This plus k will shift up if it's positive and down if it's negative. Shifting left or right. Tan of x minus h, cotangent of x minus h. If h is positive, it will shift to the right. If h is negative, it'll shift to the left. Distortion. Stretching or shrinking vertically. We have a times the secant of x, or a times the cosine of x. Stretching, shrinking horizontally. Cosecant of bx, tangent of bx. So here we have a coefficient outside the function, or we have the coefficient inside of the parentheses. Reflection over the x-axis will be negative tan x, or negative cosecant x, and over the y-axis would be secant of negative x, tangent of negative x. So having the negative sign out front will be a reflection over the x-axis. A negative sign in the parentheses will be a reflection over the y-axis. To graph f of x equals secant x plus k, graph g of x equals cosine x plus k first. The graph of g will serve as a guide when graphing secant x plus k. Let's see how this works. Compare the graphs of f of x equals secant x plus 2 in red and g of x equals cosine x plus 2 here in blue. The vertical asymptotes of the graph of f coincide with the arguments x, where the cosine graph passes through the midline, or the sinusoidal axis. So here, where we pass through the midline, there will be a vertical asymptote there and there. The low and high points of f coincide with the high and low points of g. The graph of f increases for the same x where the graph of g decreases, and vice versa. Here's an example. Graph f of x equals 2 secant x plus 1 using the graph of g of x equals 2 cosine x plus 1 as an aid. The graph of g is provided. The points where the graph of g passes through the midline provides information about the graph of f? Yes, it does. At these points, that's where there will be vertical asymptotes in the graph of the secant, just like that. The points where the graph of g has highs and lows provide what information about the graph of f? Well, they're going to share these maximums and minimums. A maximum of g is going to be a minimum for f, and a minimum for g is going to be a maximum for f. The graph of g is uphill, where the graph of f is downhill, and vice versa. Sketch the graph with the asymptotes, high and low points, and uphill, downhill resolved. Alright, so the minimum will be here, and it's going to look like that, with these vertical asymptotes. Down here, it'll look like that. Over here, we have half the graph, and it looks like that. And here is the complete graph. To graph a transformation of secant, f of x equals a times secant b of x plus c, graph its companion function g of x equals a times cosine bx plus c first. With the graph of g of x as an aid, identify the following. The vertical asymptotes of f of x coincide with those arguments where g of x equals c. The high and low points of f of x coincide with the low and high points of g of x. And the graph of f of x increases where the graph of g of x decreases, and the graph of f of x decreases where the graph of g of x increases. With this information, sketch the complete graph of f. Since sine and cosine are congruent graphs, it should come as no surprise that the secant and cosecant graphs are congruent. Given this, the approach to the graph of cosecant mimics the one for secant. To graph a transformation of cosecant, f of x equals a cosecant bx plus c, graph its companion function g of x equals a sine bx plus c first. With the graph of g of x as an aid, identify the following. The vertical asymptotes of f of x coincide with those arguments where g of x equals c. The high and low points of f of x coincide with the low and high points of g of x. The graph of f of x increases where the graph of g of x decreases, and the graph of f of x decreases where the graph of g of x increases.